In this video, we're looking at pyramids of biomass, which show the biomass of each trophic level in a food chain. So this pyramid here could represent a food chain like this, with grass as the producer, rabbits as the primary consumer, snakes as the secondary consumer, and hawks as the tertiary consumer. Now, the term biomass just means the mass of living organisms. So this bar at the bottom represents the total mass of all of the grass in the food chain, whereas this next bar represents the total mass of all the rabbits. Then the next one represents the total mass of all the snakes, and so on. The important thing to notice is that the bars get smaller as you go up the trophic levels, which means that the total mass of the organisms in each level is decreasing. So even though each individual snake might weigh more than each rabbit, there would be a lot fewer snakes than rabbits. So the total mass of snakes is much lower than the total mass of rabbits. The reason for this is that every time one organism is consumed by another, and we move up a trophic level, most of the biomass and energy is either lost or used. Only about 10% of it actually gets transferred up to the next level. So if we think about all the biomass of the grass, only about 10% of it will be passed on to the rabbits. And then only 10% of that rabbit biomass will be passed on to the snakes, and so on. Now, there are a whole bunch of reasons why only 10% of the biomass and energy gets passed on each time. But there are three main reasons that you need to know. The first is that organisms don't normally eat every single part of the organism they're consuming. For example, the hawks wouldn't eat the snake's skeleton or teeth. The second is that even the bits that they do eat might not be absorbed if they can't break them down properly, such as the scales or something. So those bits just get digested as feces, which is the technical way of saying pooped out. The most important reason, though, is that most of the nutrients that animals do absorb are used to release energy through respiration, rather than for growth. This means that the biomass gets released as waste products, like carbon dioxide and urea, rather than being stored within the organism forever. So when the organism ends up being eaten by something, it doesn't pass on all the biomass that is consumed throughout its life, because it's been using most of it for everyday functions. The last thing we need to cover is how to calculate the efficiency of biomass transfer, which is basically just the percentage of the biomass that's passed on each time. And for this, we'll need some actual values for the biomass in each trophic level. The equation is that efficiency equals the biomass transferred to the next level divided by the biomass that was available at the previous level. And we have to times the whole thing by 100 to turn it into a percentage. So if we wanted to find the efficiency between snakes and rabbits, we'd just do 15 kilos, which is the biomass that must have been transferred to the snakes, divided by 144 kilos, which is the biomass that was available in the form of rabbit biomass. Then we just multiply that by 100 to get an efficiency of 10.4%, which means that 10.4% of the rabbit biomass got passed on to the snakes. Or for the efficiency between snakes and hawks, we'd just do 1.6 divided by 15 times 100, which gives us 10.7% for the efficiency.